Hi, this is a Fourier series question. It is a numerical Fourier question. So it's number 6 and it's probably the easiest question on the exam and probably the easy question on whatever assessment you're going to get as well. So the question is, a periodic waveform f of t is defined as, and it gives you a table, t in milliseconds from 0 up to 12 and steps to 2, 2, 4, 6, and f of t, a function of time, 4.3, 6.3, and right on to 2.1. And it says where t is in milliseconds and the period of the waveform is 12 milliseconds. That means it repeats itself every 12 milliseconds, which means this here would be 4.3 and the whole thing would repeat again. And we only go as far as 10. So it says determine the Fourier series representations for f of t up to and including the third harmonic, and then find the percentage third harmonic. So the first part is worth 20 marks and this little part, the third harmonic, is worth 5. Now these are the four equations that are given under Numerical Fourier in the back of the exam book, and you'll have them yourselves. And it's f of t equals, so this is the Fourier series representation, f of t equals a0 over 2 plus the summation from n equals 1 to infinity of an cos 2n pi t over capital T, which is the periodic time, plus bn sine 2n pi t over capital T, which again is the periodic time. You can see the angle in here, 2n pi t over t, is the same for the cosine and the sine, and the an is connected to the cosine and the bn is connected to the sine. So the values we're given are in the formula are a0, 2 times the mean of f of t, an 2 times the mean of f of t cosine 2n pi t over t, and bn 2 times the mean value of f of t sine 2n pi t over t. So what we have to do first is we find the a0, the an's, and the bn's, and when we're using these three formula here, and when we find them, then we put them into this formula near the end. So when t is 12, right? So now we're starting the answer. The periodic time is 12. That means capital T is 12. And I'm looking at the angles because I'm going to do this as a table and I need to get the headings of the table right. So to get the an's, I'm going to have to use cosine 2n pi t over capital T. So now I need to sort out this angle here. So it's 2n pi t over capital T. But capital T is 12, so it's 2n pi t over 12, which is n pi t over 6. And when n is 1, now we're asked to go up to the third harmonic. That means we have to go up to n equals 0, 1, 2, and 3. The third harmonic, we have to go up as far as n equals 3. So when n equals 1, the angle is going to be 1 pi t over 6. When n equals 2, it's going to be 2 pi t over 6. And when n equals 3, it's going to be 3 pi t over 6. Now you could make this down to pi t over 3, and you could simplify this to pi t over 2. But I'm just leaving it like that because if I use the fx function later, it'll work out as that. It'll be fine like that. Okay, so that means now I have to start filling in the table, right? So I'm just going to take this table here that they gave in the question and write the TS, I'm writing it vertically downwards, and the f of t, I'm writing it vertically downwards. Okay. Then, to get the angle that goes up here, if you look at, I'm looking for the an's, right? So I'm looking for, there's a formula for the an's there, and it's f of t cos 2n pi t over capital T. Now I know my angles now are n pi t over 6 when I put the 12 in there. So it's going to be cosine n pi t over 6. When n equals 1, cosine n pi t over 6. When n equals 2, cosine 2 n pi t over 6. And when n equals 3, cosine 3 n pi t over 6. And then, according to the formula for the an's, you have to multiply them by f of t. So now I say f of t times this, plus f of t times that, plus f of t times that, and I put those into those three columns there. F of t cos pi t over 6, f of t cos 2 pi t over 6, and f of t cos 3 pi t over 6. Okay, so all I have to do next is plug in the values from the calculator. Now, it is very important to remember to put your calculator in radians. Radians, righto, radians. Or you'll get weird answers, okay? And it's always worked in radians, but if you see pi inside an angle, it means radians. That's your indicator. Okay, now I could like individually do each one of these. I could say cosine fractions pi t over 6 and let t equal 0, so it will be, well, I know that, but anyway, shift pi multiplied by 0 divided by 6, close the brackets, pi t over 6 when t is 0, and I would get 1. That's fair enough, and I could do that individually. I could keep going back and changing the t value from 0 to a 2 and so on, and get the values the whole way down. So that's a half. I could put that in there now, right? But so that's cosine pi times 2 over 6, which gives me 0.5. But if this was a very long list, so long as these times here are going up at the same intervals nice and evenly, I could use the f of t function. So yeah, the f of t function. So that's what I'm going to use, table 3. And I've already checked this calculator is in radians. Okay, so now I'm going to put in f of t equals cosine fraction shift pi multiplied by, instead of t you use x, alpha x all over 6. Close it, right? So this is the function here, okay? And then it starts at 0, so the values of t, which would be x here, starts at 0, finishes at 10, it doesn't go up to 12, okay, it finishes at 10, and it's going up in steps of 2, and we get 1, 0.5, which I've already done, minus 0.5, go down 1, minus 1, minus 0.5, and then 0.5. You can see there's a pattern to it. So now, if I want to find out cosine 2 pi t over 6, go back, press AC, go back into your function, and write a 2 multiplied on top of it. And then start at 0, finish at 10, and go up in steps 2. And we'll get the f values here. So it starts again at 1, which it should, yeah, because it's cosine of 0. 1 minus 0.5 minus 0.5. And it's grand that they're similar. It means the calculations will be easier. 1 minus 0.5. Weird, minus 0.5. Okay. And then we'll change it to 3 pi t over 6. Go into the AC button. Go back or forward, whatever way. And change that to a 3. 3 pi x over 6 in our case. Start at 0, finish at 10, and go up in steps of 2. And our values are 1, minus 1, 1, minus 1, 1. It just goes 1, minus 1, 1, 1, minus 1, 1, minus 1, 1, minus 1, 1, minus 1, and finishes on minus 1. That's it. So now all we have to do now is multiply. I'll go out of the fx, go back into compute, 1. Multiply the f of t by this. So for this one here, it's going to be 1 times 4.3, which is 4.3. 0.5 times 6.2, which is 3.1. Minus, because that's a minus, 0.5 by 6.5, that's 3.25. Yep. And then minus this, minus 4.2, half of this, and it's a minus as well, 1.9, 1.95, just do it, 1.9 divided by 2 equals 0.95, yeah, 0.95, and then 2.1, and that's plus, so it's going to be 1.05. So let's just check. So if we check here, we have 2 positives, 3 negatives, and a positive. 2 positives, 3 negatives, and a positive. Grand. So now then, this one here is f of t again, multiplied by cosine 2 when n equals 2. So it's going to be this. So that's 4.3. In fact, that's 4.3 the whole way across. 4.3. and then now it's minus 0.5 by this, so it's going to be minus 3.1, and this is the same as this one, minus 3.25 and 4.2, because hold on, that's a plus 1, yep, minus 0.5 times that, and that is going to be minus 0.95, and minus 0.5 times 2.1 is minus 1.05. Okay, and then the last column, it's going to be f of t multiplied by 1, minus 1, 1, minus 1 the whole way down. So really, I'm just going to alternate signs. Minus 6.2 plus 6.5 minus 4.2 plus 1.9 minus 2.1. Okay, so according to the values for an, it's the mean value of f of t multiplied by these. So I'll have to get this, this, and this. And for a0, it's the mean value of f of t. I have to get this. I don't need to add up that one or any of them, so I can ignore them. So now I just add up these columns here, see what I get. So 4.3 plus 6.2 plus 6.5 plus 4.2 plus 1.9 plus 2.1 equals 25. I did this earlier and I got 25.3. Took that down wrong. Oh, that should be 6.3. Oh, and then that means this is 3.15, 3.15, and 6.3. Okay. Well, let's sort it. So remember to check your stuff, right? So the answer to that is 25.3. Okay, now I can add these ones up. That's sorted. It only went up by 1, which is 0.5 if you're doing half of it. So when I add these ones up, I'll add them all up. I'll tell you what I got previously. 0.1. When I add these up, 0.1. And when I add these up, 0.1. Now that is weird to get the same answer each time, but that's just the way it worked out in this case. Okay, so then again, we're going to do the B ends now. We've done the A ends, we've got the values for the A ends. Actually, I could finish these bit off down here now while I've got this table done. A0 is going to be 2 times the mean value of f of t, which is 25.3 divided by 6. Because there are 6 numbers, 1, 2, 3, 4, 5, 6. All right, so this is A0. Let's find out that. So 25.3 multiplied by 2 divided by 6 equals 8.43. 3 with a wee dot, right? So that equals A0. Equals A0. Put that, because I will need this later. Okay, then A1 is 2 multiplied by the mean value of f of t cos pi t. It's multiplied by the mean value of this, which is going to be 0.1 divided by 6, again because there are 6 numbers, 1 over 30 or 0.03 dot equals A1. Then A2 is going to be 2 multiplied by 0.1 divided by 6, this one, which is actually the same, 0.03 dot, and then A3 is the same value as these are the same, 0.03 dot. Rather weird. Equals A2 equals A3, but done. Right, so that's the A's done. So now we have to do the B's. To do the B's again, you use the table, and it's basically the same headings here, except wherever there's a cosine, put in a sine. That's it. So cosine is going to become sine pi t over 6, and this is for n equal to 1. When n equals 2, it's going to be sine 2 pi t over 6. And when n equals 3, it's going to be sine 3 pi t over 6. And then it's, according to the formula again, it's f of t multiplied by these. So it's f of t multiplied by this one, sine pi t over 6. Then the next column is f of t sine 2 pi t over 6. And the final one, f of t sine 3 pi t over 6. And we fill out this now. See, this is a sine of t, and t is 0. Sine of 0 is 0. So the whole top row of this is 0, 0, 0, 0, 0, 0. That makes it a bit easier. But I think I'll just do the table function again. When I go through the table function, I get 0.866, 0.866, 0, minus 0.866, and minus 0.866. And when I do the table function on this as well, it's the similar numbers, just different signs. 0.866 minus 0.866, 0, 0.866, and minus 0.866. So we have two pluses, a minus, two pluses, and a minus. And then, if we've sine 3 pi, that's sine pi, 6 pi, sine pi in the end, that works out as, and they are all 0. You can do it on the fx and they'll work out as 0. So that means I could go for the last one. First one, I could say f of t multiplied by the sine of this one. That's these two here. That's going to be 0 the whole way down. That saves me a lot of hassle. These ones here are still going to be 0. So all I have to do now is work out 6.3 multiplied by 0.866 to get that one in there. Which equals 5.4. 5.46, or 5.456 if you want, 5.456, and then 6.5 multiplied by that. Yeah, 6.5 multiplied by 0.866 is just slightly. Oh, I forgot the point. Oh, wow, I deleted the point. There we go. And you get 5.629. Then 1.9 multiplied by 0.866. 1.9, and it's a minus in this case, 1.64, 1.645. So it's 1.9 multiplied by a minus, so that will give me a minus. And here it's 2.1 multiplied by a minus 0.866. 2.1. That will give me 1.819, but it's minus, so that's a minus, right? So here I have 4 pluses and 2 minus, 4 pluses and 2 minuses. That's grand. And then the next one, it's the same numbers, right? So 5.456. This one, it's just minus 5.629. That'll just be plus now, 1.645, and this one will stay at minus 1.819. Okay, so now what I need to find out is I don't need the f of t. That only works for the A0 one. I don't need this, or this. I only need the last 3 columns here that have the f of t. So if they add up all of that, and when I add up all of that, I get 7.621. 0 for that one, and if I add up all of these, I get minus 0.347. So that is my, I could now say, find from these values, I can find my b values. Okay, so the b value is 2 times the mean of f of t, so it's 2 multiplied by, from my table here, the f of t, right, sine pi t over 6, 7.621 divided by 6. Oh, no, this here's the mean of that, that's that. I'm dividing it by 6 because I'm getting the mean, which means I'm dividing it by the number of numbers, which happens to be 6. Okay, see what that works out as. 2.54. Okay, then the next one, B2. So this here was n equal 1, n equal 2, n equal 3. So B2 is the mean, which is going 2 multiplied by the mean of this, which means we add them all up and we get minus 0.347 divided by 6, which will give me, I think I worked that out somewhere else, minus 0.116. And then the last one, well, it's 0, so it's going to be 0 if you're multiplying by 0. So now I have A0, A1, A2, A3, B1, B2, B3. And this is the formula we're given at the beginning, and we're ready now to put these values into this formula. So I'm just going to write this formula out in long, just for the n1s, n2s, and n3s. So f of t is equal to a0 over 2. Now, because we're asked for the third harmonic, we've only gone up as far as n equals 3. So it's going to be plus. Now, when n equals 1, it's going to be a1 cosine 2 pi t over 12. The n is 1 and the periodic time is 12. So I can leave it like that. I can change that to pi t over 6. Right? Plus b1 sine 2 pi t over 12. Which I have written as, for these ones, 1 over 6. I had that as over 6 instead, you know. Right, that's A1 and B1, but we have to do it for n is 1, n is 2, and n is 3. So when n equals 2, it's going to be plus A2 cosine 2 pi t over 6 plus B2 sine 2 pi t over 6. And then when n is 3, plus A3 cosine 3 pi t over 6 plus B3 sine 3 pi t over 6. So we just have to put in the values we already calculated for A1, A2, A3, and A0, and B1, B2, B3. So that will be f of t is equal to A0, which worked out to be 8.43 divided by 2, plus A1, which is 0.03 times, that's A1, we keep the cosine, cos pi t over 6, plus B1, which is up here, 2.54, sine pi t over 6, plus A2, which we calculated as the same as A1, 0.03 to infinity, cosine 2 pi t over 6, plus B2, which is now minus 0.116 sine 2 pi t over 6, plus A3, which was 0.03 to infinity, cosine 3 pi t over 6. So the n's are n is 1, n is 2, and n is 3, A1, A2, A3, B1, B2, and then plus B3, which was 0, so that's just 0, plus dot, 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 because there are more beyond n equals 3, but we just haven't calculated them. So this is our Fourier series representation of that function. So then the last thing we had to find was, that was that part done, was to determine the percentage third harmonic. So to get the harmonics, it's basically we're just going to get we've got the harmonics, all we're going to get now is the amplitudes, right? So the amplitude for the fundamental or the first harmonic is going to be the square root, A1 is going to be the square root of A1 squared plus B1 squared. A2, which we don't need, but I'll just do it, is the square root of A2 squared plus B2 squared. And A3 is equal to the square root of A3 squared plus B3 squared. So the capital A stand for the amplitudes of the waves. So in this case, A1 is the square root of the A1 squared. And for A1, we got 8 point, what do we get for A1? Not 8, that's A0. A1, we got 0.03, 0.03 to infinity squared plus B1, 2.54 squared. That. Okay. And I worked that out earlier as 2.54. 2.54. The 0.03 squared is makes very little difference. And then A2 is going to be 0.03 to infinity squared plus, that was A1. So now B1 is minus, it doesn't make any difference if it's squared, so it's 0.116 squared. And that works out as roughly 0.169. And then the A3, the amplitude for the third harmonic, is the square root of 0.03 squared plus nothing. So it's 0.03 to infinity. Okay, now we're asked for the third, the the percentage third harmonic. So basically the percentage third harmonic is the value of the third harmonic, 0.03 to infinity, over the value of the first harmonic, 2.54. That's the amplitudes, multiplied by 100%. And that will give us 0.033333. I'll just do it like that, to infinity, divided by 2.54 multiplied by 100 equals 1.31%. 1.31%. That is the percentage third harmonic. Percentage third harmonic. You could also be asked, I may as well do it now on this little tiny square, to draw a sketch of the amplitude. So that would be n here as the values. So we could have 1, 2, 3. That's the three values we have. 0. I'll leave that out. And then the amplitudes are going up here. The amplitudes n. So we have our highest amplitude is 2. So we could have 1, 2, 3, and in there 2.54. 1, 2, 3. So the first harmonic is at 2.54, about there. They're discrete, they're separate waveforms. The second harmonic is 0.169 and about there somewhere. And the third harmonic is tiny, you can barely see it, it's so low. That's our three harmonics. Okay, thank you. That's it, done.